This is the Amp Hour Podcast. Released January 6th, 2019. Episode 424. An interview with Julia Truchsess. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Julia Truchsess of Pragmatic Designs Incorporated.
Welcome, Julia. How you doing?
Very well, thanks, Chris. And you?
I'm good. Glad to be, like we were talking about right before the show, glad to be back from the holidays. And, even though we didn't take full breaks as consultants over the holidays, it's good to be back, I guess.
I'm glad they're over and ready to get back to work.
Yeah. So we actually quote unquote met on the Kicad forum, and you're a Kicad user, but a longtime consultant.
No, I'm a Kicad user, Chris.
Oh, okay. All right. It's gonna be like that, huh? Starts early.
The Great Divide.
The Great
There are
Divide.
two kinds of people in the world.
That's good. You like we were talking about as well before the show. You kind of have a long history of consulting, but how did you get started? And then maybe we can work our way forward in time to where we are today. My electrical electronics experience started with Lionel trains under the Christmas tree when I was a very young girl, probably 3 or 4 or 5. My father was a chemical engineer, and my older brother was very mechanically inclined, and the Lionel trains under the Christmas tree were a big part of our childhoods. So, there were transformers and there were circuits and there were lights and motors and buzzers and solenoids. And that was really the start of it. That's great.
And I gravitated towards it. And my parents were very good about encouraging it. They didn't buy me whatever I asked for whenever I asked for something, unless it was something to do with electronics. And they pretty much got me whatever I needed, or they helped me get it.
Yeah.
When I was about 10, my mother was the bookkeeper at the local country club, and she got me the gig running the concession stand.
Nice.
We would make sandwiches and get the potato chip guy to come around and so forth. And I made like $100 over the summer, which was a fortune in those days. And with that, I bought my first used oscilloscope from the local TV repairman.
Awesome. What was the model of that first scope?
That was a Hickok. I don't remember. It had a free running sweep. It didn't have a triggered sweep, but it glowed, and I could finally see what signals looked like.
Right.
And then I think that following Christmas, I think they got me a Heathkit scope, which again still wasn't triggered sweep, but putting Heathkits together was a great experience. I built a Heathkit power supply and that scope, and my dad and I built a Heathkit hi-fi. All that kind of stuff. And I had one of those breadboards with all the springs on it that you could clip components to.
The 201s.
Yep.
Yeah.
And so, and my parents were very encouraging, and that was a big start.
That's awesome. And I assume that like having that first scope too really helps with the next scope and the next scope. I was just remember my days of like just DMM days, and like it helps a lot, but man, yeah, that first scope really makes that difference.
Yeah, you have to be able to see the signals.
That's great. So, I mean, okay, so that's early days. Then how did you get into professionally then?
I was always into rock and roll ever since seeing the Beatles on the Ed Sullivan Show in '64, and that's all I really wanted to do was be a rock star ever since that. So I didn't really do anything professionally with electronics until I was 20. I had dropped out of college in '75 and hitchhiked to Wisconsin to join a band who had advertised for a bassist in Rolling Stone.
Yes.
Rehearsed with them for 6 months in Wisconsin, and then we all packed up and moved to New York. And when I got to New York, my drummer had the New York Times open to the page for auto parts technician because he was an auto parts guy, and just a few lines up from that was an ad for an audio technician, and that was an ad for a job from Electro-Harmonix.
Oh, really? Okay.
Which was only about 2 blocks from where we were living, so I went over there and they hired me on the spot.
Wow. Okay. And so people don't know that Electro-Harmonix is a effects pedals. What do they do?
They were one of the very first effects pedals manufacturers, and at various times the biggest. They were started by Mike Matthews, who is a force of nature unto himself. In the late 60s, he was a promoter. He worked with Jimi Hendrix and a lot of other big stars back in the day. And he collaborated with a circuit designer from Bell Labs, a guy by the name of Bob Meyer, who came up with a two transistor circuit that would overdrive the input of a guitar amplifier. And thus the distortion box was born.
Nice.
They followed that up with the Big Mouth Pi, which is a legendary fuzz box that Hendrix used. And the rest is history.
I had a brief. I'm more piano these days, but I had a brief guitar phase, and of course, I went through the lusting after various pedals, and I laugh now about the analog man, the guy who changed out a single transistor on my Ibanez IB, or what is it, the something 9, the IB9 or something like that. But sorry, the TS9. And it's overdrive pedal, and like I paid like $100 extra for some guy to change out his Romanian transistor and like a JFET amp, and I think about it now and I'm like, oh boy, that was some wasted money.
Now was very good to me. They Mike hired me just on the basis of liking me, and I said I could do it, and he trusted me. And I spent about a week on the production line tuning the DC offset trim pots on the analog delay lines. Mm-hmm. And then I went into his office and I said, I have an idea for a guitar synthesizer. I really want to design a guitar synthesizer. And he said, okay. He gave me an office and said, run with it. And wow. The result, a year and a half, 2 years later, was the EH8000 guitar synthesizer, which was at the time the most complex product they had ever done.
Yeah.
It was entirely analog, 3-voice synthesizer, rack mounted. It was used by Steve Howe of Yes and a few other luminaries. And
I was gonna say, is that a John Scofield thing too? Because I know he does synthesizers on the guitar too.
I don't know John Scofield.
He's a jazz guy. I'm sorry about that.
Okay, compared with today's DSP based processors, it's tracking and so forth. But there was some pretty amazing circuitry in it. It was able to pull the fundamental from a guitar tone, which is quite a complex problem because of all the transients and the harmonic content. Sometimes you've got more harmonics than you have fundamental, so it's very difficult to track. And this worked without any special pickup or anything. You could plug any guitar into it and it would work.
So what is that? What are those circuits kind of? I mean, obviously there's a lot of circuits in there, but what is kind of like the basic ideas? I mean, I think about pulling out fundamentals and stuff and thinking about doing FFTs, but I'm guessing you weren't actually doing that. You were probably doing oscillators and stuff.
To get the fundamental, actually, there was one of the most brilliant circuits I've ever seen in my life. I can't take credit for it, unfortunately. It was invented by David Cockrell, who is the most brilliant engineer I've ever run into, and he's still to this day designing a lot of the Electro-Harmonix DSP based stuff.
Oh, nice!
But this was an entirely analog circuit. It was an adaptive filter. That could pretty much extract the fundamental from anything, and it was it's like a 4 op amp circuit. That was amazing. It was a low pass filter, compared the input and output, and had a servo loop where the low pass filter would track whatever you played. So
that's awesome.
Within limits, it could pull the fundamental out of anything. And then from there, it was just a matter of squaring it up and putting the whole thing into a big frequency locked loop, so that the voltage controlled oscillators that you would actually listen to as the synthesizer output would track the fundamental of the guitar.
Okay. Oh, so the idea is like basically you play a G on a string, and you're saying that all the other like harmonics of that kind of make it sound different things, but you basically say the circuit says, okay, this is roughly a G, and now I'm going to add crazy sounds to that G and make it do other things. Is that kind of the idea?
It was actually oscillators producing their own tones that would track the note that was being played on the guitar.
Oh, okay.
So it was a pretty traditional 3-voice voltage controlled oscillator synthesizer, similar to an ARP 2600. Mm-hmm. So you had voltage controlled oscillators, you had voltage controlled filters, you had ADSR envelope generators that would fire whenever you'd play a new note. So you had to do pluck extraction.
Oh, wow.
So you'd not actually be listening to the guitar output, you'd be listening to the synthesizer output, which was hopefully following the notes that you played.
Got it.
Today's guitar synthesizers are much better because they don't bother with tracking and the fundamental. They basically just process the guitar signal,
Okay.
and that's what Cockerell's DSP Genius is doing these days. But that's beyond me.
Got it. Yeah, so I guess the offset I'm thinking, not the offset, but the comparison I'm thinking of is like when I press a key on a piano, it's very easily to just program something that says when this key's hit, it is a G, and then do all your fancy stuff around it. The hard problem that you seem to solve is like detect that it was a G on a guitar string in the first place, right?
Yes, and also detect when the note is initiated, which is
Oh yeah.
The articulation detection.
Mm-hmm.
And I've run into that problem a number of times over the years, more recently in the early 2000s, or the 20 teens rather, where I had to do the same thing except with cymbals.
Oh,
but,
okay.
We'll get to that later if we're tracking my career.
Yeah. Let's keep going linearly. I like that. Yeah. Well, the audio field in my mind, at least, is like kind of a thing set apart. Does that feel like that to you? I mean, obviously, we're going to get to the fact that you've gone through a lot of industries, but do you see the audio industry as a separate thing?
Oh, absolutely. There are so many subgenres to electrical engineering, and my career focused on audio for a long, long time in one form or another. But there's there are other worlds out there that you can go your entire lifetime and never contact with. A lot of audio guys are totally oblivious to what happens in the radio world. It's very different.
Right.
But what's really important if you're moving from one area to another is a solid foundation in the fundamental principles. Electric waves and how they behave.
Yeah, of course. Yeah, I was thinking about like the again, I've had pretty limited contact with the audio world, but it seems like some of the more colloquial things that I heard some of the audio people talking about, of like warmth and stuff like that. Obviously, that was in the amplifier world, it's kind of its own kind of sub niche within a niche kind of thing. But that's what I was really thinking of.
There's so much subjectivity, especially in high-end hi-fi. I have a friend who is a published author in the hi-fi business, and he's well known as a myth buster. And he debunks all these people that are selling, $2,500 power cords that make your stereo sound warmer.
Yeah, I saw an article the other day about a Japanese gentleman who has a dedicated transformer outside of his house because he needs really, really clean power.
Yes, and oxygen-free copper.
That's right.
And audio cables that have to be hooked up in the right direction because the signal sounds better going one way than the other. Yes,
right. But you need to pay for the $1,500 guide to figure out which way that is, of course.
Yeah, there's a sucker born every minute.
It's unfortunate. Well, so what else did you do in the audio field? I mean, was it pretty similar?
When the guitar synthesizer was done in 78-ish, my band was not doing real well on the New York circuit. We were a prog rock band when punk was just happening. So we figured, let's go to England and see what we can do over there, because we were big fans of Brit rock. And so I went to Mike Matthews and I said, I'm going to quit the job and move to England with my band. And he said, don't quit, go over there and open up a service and distribution center. So
nice.
That was great. So yeah. I did. I went to England, opened up a service and distribution center, hired a technician, and set up the office there. And while I was there, electronic drums were just starting to happen. There was the hit single, I forget the artist's name, but it was Ring My Bell. And there was the pew, pew.
Oh, yeah, that's right.
Signature drum sound. So I said, well, I could do that. And I came up with the space drum line for Electro-Harmonix, which was the first really low-cost line of electronic drums. Which was, there's a lot of clever circuitry in it that I'm proud of, but the real challenge was that Mike was too cheap to tool up any new special housings for anything. So these electronic drums had to go into the same sheet metal boxes that he was using for fuzz boxes and phase shifters.
Yeah.
So that in itself was challenging, but the space drums were fun. And I've always had a fondness for interesting percussion stuff. So So that was fun.
And when you say
In
space drums, are these actually like hand actuated, or are they actually hit it with sticks?
No, you would hit them with a stick.
Okay.
I took the sheet metal box that they were using for effects, which they had a 3 knob version and a 5 knob version, and I glued a crystal microphone to the underside of the metal, and I put a leather pad on the top side, and you could whack it with a stick.
Huh,
Um,
that's
at
great.
least a few thousand times until the crystal microphone fell apart. But
Right, and I'm sure that some drummer. So I used to be a drummer as well, and yeah, that I beat the crap out of a bunch of stuff, and that's a tough thing
yeah,
to
they
do
were
though. Like
not.
it's a different consideration of the physical needs.
Oh yeah, they were not really rugged, and they were not really too drummer resistant, but they were innovative nonetheless. And I think they made a sensation. There was one called the Crash Pad, which was a white noise generator that went through a sweat filter, and it was really really versatile. You could do a lot of stuff with it, and I believe that Soft Cell used that on their hit single. Where did our love go? Which was
I don't.
segued.
I think I only know one soft cell song.
Yeah, well, it's that one.
Okay.
It's that one.
Okay, nice. Well, that's great. I mean, and that's the other crazy thing is that you see. I mean, you see these things that at the beginning as like making it as a circuit that makes a noise that does a thing, and then some artist goes and well, many artists take it, and then some of them obviously make the big hits with it too, which is crazy.
Yeah, it's very gratifying when that happens. Not
Yeah.
too often, but it's gratifying. Yeah.
Do you? So can your ears still pick it out like when you hear a recording, like any day of the week kind of thing?
Yeah, it's most likely mine if it was in that very very early era when the soft cell hit came out. Of course, there were countless knockoffs and different ways to do it. So sure, if you hear that sound now, it could be anything because there are samplers and
Yeah.
all kinds of stuff. But back in the day, in 1980, if it was that sound, that crash sound, it was probably my box.
That's cool. That's really cool. I mean, yeah, and it's crazy too. Is that there's like the vintage crowd as well that are like, no, 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 I need to have the original to have that original sound, and they're probably collecting your gear as well.
Yes, in particular the space drum line. They became very, very rare. The crash drum, the space drum, the super space drum, and the rarest of them all, this thing I did called the Clockworks, which is sort of a playable drum sequencer. And as of, I don't know, 6 or 8 years ago, they were going for thousands on eBay.
Oh my goodness.
And Electro-Harmonix saw the demand, and I, of course, reminded Mike, when we would correspond once in a while, I said, hey, I saw Clockworks on eBay for $2,500.
Oh my god.
And so he actually reintroduced the line. He reintroduced, I don't know, 4 or 5 of the products, I guess, about 3 years ago. And they put them in nice die-cast metal boxes now because their packaging has gotten more sophisticated. But the thing that was really gratifying to me was 33 years after I originally designed them, they used my circuitry without any modifications.
Oh, really? That's awesome. That's really awesome.
My original circuitry is in those re-releases, and that was just that was a high point for me.
Yeah, that's amazing. So, like, what is the? I mean, they didn't switch it over to. I guess the industry as well. Like the audio industry is still doing a lot of through-hole type stuff, at least for the legacy.
Well, I think I'm sure they went to surface mount parts, but they used the circuit design.
Got it. Well, that's super cool. So, how long were you at Electro-Harmonix for?
In '81, they started having all kinds of problems. Their quality was a little bit dodgy due to the mechanical construction. They had circuit boards loosely hanging off of potentiometer leads, and the stuff just wasn't rugged.
Right, especially for like musicians on the road, that matters quite a bit.
It was pretty cheesy. And as soon as there were alternatives, there was Japanese competition. There was a company called MXR in the States that had a nice rugged die-cast box, and those guys just kicked EH's ass. They really ate Mike's lunch, and he also had union problems, and he overextended himself. He had Delusions of Grandeur. He bought the former headquarters of the Otis Elevator Company, which was a block-sized building in Manhattan. He
Oh
bought
my.
an estate he bought Andy Warhol's estate on Long Island, waterfront in Montauk.
Oh wow.
He just he got overextended, and it all collapsed around 81. So I had to look for more work, and I landed a job around the corner from EH at a company called Swartztrauber-Segan, and they were involved in consumer electronics and toy kind of stuff.
Mm.
They had created the world's first musical Christmas ornaments.
Oh really?
you had a string of plastic bells that would play Christmas tunes.
Wow.
And they made a lot of money on that. And at the time I joined up with them, they were in the process of, the original ones were microcontroller based, 4-bit COP microcontrollers, and they were in the process of transferring that over to custom VLSI chips. And that's when I joined up.
Really? Oh wow, that's super cool. I mean, I open greeting cards these days and they start singing to me, but I assume that at the time this was actually pretty significant to have that happen in a low cost consumer product.
Yeah, we actually did the first musical greeting card that in the summer of '83. We took the VLSI chips that had been in the Christmas ornaments and we licensed the technology to Hallmark cards.
Oh wow!
And in the summer of '83, we made 5 million greeting cards for Hallmark.
Oh my god!
Yeah. I didn't design the VLSI chip, but I designed all the high-speed production test equipment that was used on the factory floor to test the greeting card modules before they went into the cards.
Is this you needed like automated testing because the person who previously had to listen to each card actually went insane from hearing the same tune over and over again?
Well, yeah, when you're making if you do the math, if you want to make 5 million cards in 3 months, you have to be able to test them very, very quickly. So actually, this tester could test the entire ROM contents of the chip as well as all the analog parameters of it, standby current, operating current, output drive, so forth, plus the integrity of the ROM contents. It could do it all in about 8 or 10 seconds, I think.
Whoa, that's awesome.
And and we built about 15 of these testers that were used on the production lines in Hong Kong.
Nice.
Back in the day, they still made stuff in Hong Kong, which they don't do anymore.
Right. What was the process node that the VLSI was on?
I think it was PMOS. Actually, that was the lowest cost process, and this was very low, very cost sensitive. So it was PMOS. It required like 4.5 volts, so we had to put these Polaroid flat batteries, which were the only flat batteries you could get at the time. But that's what was available in the day.
Nice. So what was the design cycle like back then? I mean, was it starting at a circuit and then working with a layout engineer? Were you doing the layout? Like how did that all work?
The VLSI development process would be you would draw it up and then you'd make a big wire wrap breadboard. I didn't work on the original greeting card, but I did a follow-on design, which was a dual voice melody harmony chip, actually. So it had 2 voices. You could play harmony with it, and it also had a little percussion generator as well. So I did that one. And yeah, you'd make a big wire wrap board. It would be about 15 inches by 10 inches and just covered with dip sockets and entirely put together with wire wrap. And you would prove out the design with the wire wrap board, and then you'd take it to the chip guys and they would turn it into lithography masks.
Yeah, right.
And we'd go over to the chip guys out on Long Island, and they would have the masks all laid out on the floor of a room about 30 by 30, and we'd all take off our shoes and walk around on the masks in our stocking feet.
Yeah.
Well, this transistor over here,
right.
It'd be about 3 inches by 3 inches each transistor.
Yeah. And that's what I'm curious about too, is like, so you were designing at the transistor level as well, versus like, I think these days it's much higher cell level type stuff, right?
Yeah, transistors. And in those days, it was more building blocks. I designed with 4000 series CMOS logic. But I've always enjoyed designing at the transistor level, particularly in the analog stuff. You could do really fun, clever stuff with the discrete semiconductors, and I still do it. I still put in individual transistors as level shifters and so forth.
Yep.
I'm not going to put in a 50-cent IC when a 2-cent transistor can do the job.
That's right.
And nowadays you can get the bias resistors built in, so it's a single component to do a level shift.
Yep. What did the ATE system look like then? Like ATE is automated test equipment?
Yeah, so it had, and for this one, it had to be designed quickly. It had to be pretty cheap because we were going to make a bunch of them. We ended up making 15 of them, and it had to be something that I already knew how to do. So I just built this board based on a 4-bit microcontroller, which I had learned how to do by developing a talking car horn for these guys in the previous year. So I got pretty good. I got pretty good with the 4-bit COPS processors, writing an assembly language, of course. So I based those chip testers on that. A year or two later, they got the Source Driver Seagate sort of split into two companies. Another one was called Quad Logic Controls, and they were involved in power metering. They had a remotely readable power meter that could be retrofitted to large apartment buildings without doing any additional wiring.
Oh wow.
And so they needed ATE for this power metering. I didn't design the power meter, but I designed the tester for it, and that was a not cost sensitive design. So it was based on a DOS PC, and I'd spent 3 months developing the hardware, which was a bunch of big boards and a whole spring-loaded bed of nails platform to put the power meter board onto. And as soon as the hardware was done, I got on a plane for Hong Kong, and I spent 6 weeks in Hong Kong writing the code for it. I wrote 10,000 pages or 10,000 lines of PLMX code, which
I guess I know that one.
I don't know if there are any remnants of PLMX around anymore. It was a pretty good language. I remember enjoying writing in it, but I don't remember a bit of it. But it was a huge program, and it was a wonderful experience to be to be isolated like that in a foreign country where I had nothing to do but work, and it was great. I would get up in the morning, go to the factory, program for 8 hours, go out to dinner, and go back to the hotel, go to sleep, and do it all again the next day.
That's great. And that was was that like doing a power line communication though? Like how was it actually communicating with those boxes?
Yes. That power meter worked on power line communication.
Awesome. Yeah, I've actually never heard, I mean, I always hear about it, but I never actually heard about like practical uses of it. I know it can work. I just never have actually seen it happen in the real world scenario.
Yeah, the retrofitting power meters to buildings was a very good business model because it was obviously prohibitively expensive to run a separate meter to every apartment in a building. Landlords would never do that, so everybody had to get estimated bills, which nobody enjoyed.
Yeah.
So with this scheme, they could do individual metering for every apartment without changing the wiring in the building and read them all remotely.
That's great. Could you explain power line real quick?
You basically you take your digital data and you modulate a high frequency carrier with that, and you couple the high frequency data, a couple hundred kilohertz or whatever, onto the power lines with capacitors or inductive networks or whatever. So you superimpose the high frequency modulated carrier onto the power line, and you have receivers that can pull it off and demodulate it at any point in the network.
Yeah.
There's a very popular home remote control technology that's been out since the 80s called X10 that worked the same way.
Oh, okay. So that's another, I guess I just never had experienced it, but that's like a commercially successful one as well.
Yeah, it was originally developed by BSR, I think, and then Radio Shack picked it up. It's been supplanted recently by RF solutions like Z-Wave and Zigbee and so forth, right. But yeah. I actually still have some X10 stuff working in my house.
Oh, really? That's cool.
I like remote control lighting in my house.
Yeah. So that's like the original IoT, huh? Sorry. Yeah. So what about after that? So I'm scrolling up the page, and I'll definitely link the gallery page for everyone to see all the pictures and everything. But it suddenly gets very colorful and and blinky looking. So what changed?
Well, let's see. So I did a few more things for these guys, more toys. I took a talking plush toy that I had developed for them, and we did a custom chip for that, which never got produced, but it was an amazing custom chip. And then in 86, I decided I needed more money. And I went to my boss and I said, I need more money or I'm going to leave. And he said, see you later.
Oh no.
At the same time, there had been a recent toy industry article written about the company, and I was featured in that article. So I had gotten a call from a headhunter who said, hey, I got this toy company, Playtime Products, and they're looking for somebody to go over to Hong Kong and run their operation there. And I said, sure, I'll do that. And we went through, a little bit of back and forth on that. And eventually he came back and he said, you know what? I've decided I want a real engineer for that job. Thank you very much.
Ooh, that's
He said, but why don't you be a consultant and I'll pay you to develop, a couple of items here and I'll hook you up with some people. And that was really the start of my independent career. So I quit my job, bought a house, and started a business all at the same time.
wow. That's a lot of stuff.
Yeah, I pretty much lived in terror for the next couple of years of being able to make the mortgage and so forth. But yes, I got into the wild and crazy world of toys.
I wanted to go back to the real engineer thing. So what the heck is that? Because it sounds like you had like 12 products under your belt by that point. So was this a degree thing? Is that what we're getting at here?
I think it was probably the degree thing, yes. I was, perceived as being more of a free spirit, creative type rather than, work out all the equations type, which is, more or less accurate portrayal.
Okay. But still, like I disagree with the real engineer thing. I mean, I would have
I was more seat of the pants and more pragmatic, as the name of my company will attest.
Yeah.
But I always just had a good intuitive feel for it. As I mentioned before, having started at a very young age. So
yeah, I'm not pushing back on you here. I would have been pushing back on that person who said that to you. That's what I'm really getting at. But I guess you left anyway. So, or you decided to do the consultant thing anyway. So
yeah, so I had one job in hand, and I figured, okay, we'll do that and see where it goes. And as soon as the word got around, there were a couple of inventors that were feeding product to this particular toy company, and they had no inside electronics. So once they knew I was available and that I did good work on time and on budget, the work just kept coming and they just kept feeding me more and more jobs. So
yeah,
I worked for 5 years out of a spare bedroom. And then in 91, I rented an office up the street and I hired my first employee. And then things really exploded because what I found with employees is that it's more than the sum of the parts. It's really a multiplying effect. So it got to the point where I had a half dozen people working for me, and so I was the idea person and the rainmaker, and I would sketch it out and I'd hand it off to the to one of my people and say, "Here, go do this." So it was yeah. I didn't have to sit there making prototypes anymore. I could tell my lab technician, "Okay, build this." All I would have to do is sketch it.
That's great. And so, can you explain the toy? We've had, I think, 2 or 3 guests in the past who have done some toy stuff. Can you explain your take on the toy industry, especially in the time frame you were doing it?
It's from an inventing standpoint, the idea of being a toy inventor, it's very much like the music business. You can work for years and years and years, putting out stuff and not have a hit, and then you can have one hit and it'll set you up for life. So,
oh, really?
It's pretty much a crapshoot. Back in those days, electronics was magic, and there weren't that many people doing electronics and toys. So I was very much a guru,
Yeah.
and it was especially in the '90s exploded with the advent of the Taiwanese voice chips, and for a time we pretty much had a lock on developing with those. And so it was really the halcyon days of my company. These days, the barriers to entry have gotten much lower with the maker movement and the democratization of electronics. There's a lot more competition.
Yeah.
And also back in those days, the toy industry itself was very different. You had medium-sized companies, you had small companies, you had small retailers, medium retailers. Kids played with toys a lot more than they do today. So what's happened today is you have many fewer toy companies. They've all been gobbled up by the big guys. So there aren't any more Playtime products. There aren't very many Tycos anymore. There's Mattel, Hasbro, and Spin Master. And you don't have the mom and pop toy stores anymore. You have Walmart, Target, and you used to have Toys R
Toys
Us.
R Us, right?
And
Rest in peace.
yeah, and of course Amazon. So it's much tougher. And of course, kids don't play with toys anymore. They play with their phones and their iPads. Used to be girls would play with dolls up until 12, and now they don't play with dolls past 6 or 8.
So it's almost like a compression of the industry then. It's like the...
Right. Yeah. And there's age compression. As I say, the kids don't play with toys for very long anymore. Price points have gotten brutal, absolutely brutal. We used to be able to get $40 for a feature doll, and they'd put it on TV,
Oh, wow.
and you'd sell a million pieces. Now it's $14.99.
Yeah.
So the mandate from the toy company these days is, give us something that's absolutely a wow factor and magical and nothing that anybody has ever seen before, but it can't have more than 99 cents worth of electronics.
Oh my god. Yeah, I was doing some of the math in my head. Like, so $14.99 retail price, that can't be there's barely any material in there, and that's got to be packaged,
Right.
splitzed up, and everything, right?
Yeah, it's like $5 out of the factory, so you've got a 70-cent electronics budget. So
Oh my god.
It's just brutal. But we had a great run when the low cost compressed speech chips came out of Taiwan. I was terrified at first because all my sounds prior to that had been made algorithmically in 4-bit microcontrollers. How can I make an engine sound or a musical tone by having software loops? And then these chips came out where you just would record a sound in them, and they'd put that in the mask ROM, and it would play it back. And I said, "Oh, this is going to put me out of business." But actually, it turned into the biggest opportunity I ever had because I got to be one of the first people who learned how to use them. The tools were horrible. Everything, all the documentation was in Chinese. The coding systems were not available in the States. You had to go to Taiwan to use them. But I got to be good at it, and we became pretty much the number one go-to house for most of the toy companies in the States. So we had a
So
great
when they
run.
said they wanted a sound in there, they knew they got your name somehow to give you a call and get it implemented, that kind of thing.
Yeah, we got a reputation as being the sound people in the business. And in 1991, I had a hit with Rumbler's toy trucks, which actually was not a recording chip. It was a circuit that I patented that just used a couple of CMOS gates, digital gates, but they were used in an analog way to make something that sounded vaguely like a revving engine. And that item did very well, and that was my first royalty-bearing product. And the cash flow from that enabled me to take on less and less contract work over the next year or two and focus on inventing more.
Got it. So doing like your own development based on your ideas and then just selling it to someone pretty much.
And yeah, you license it and you collect a royalty. And, if you load the pipeline with product and the royalties start coming in, it frees you up to do more stuff. You don't have to just keep doing contract work to pay the bills. So by the late 90s, we were pretty rolling along, and we had a good mix of work for hire and royalty stuff.
That's great. That's great. I have to say before we move on, I think one of your products was one of my first, the rhythm rods. It was like a clip-on thing. I think that was one of my first drum toys, and that's how I got into drumming. So like, thank you for that.
You're very welcome. Yeah. My career-long love of electronic percussion.
Yeah. Well, that's pretty crazy. Okay, so you were in Hong Kong in the 70s and 80s, right? And Taiwan
83 was my first trip to Hong Kong.
Okay. And then Taiwan in the 80s, 90s, it sounds like, and I'm guessing other places. What was that all like? Because I mean, obviously, everybody talks about Shenzhen now, but like, I mean, back then, what was it like at all?
The first time I was in Shenzhen was in 87. And I think the car that I was in was the only private car I saw the whole time I was there.
Oh, wow.
It was people riding bicycles with coolie hats, and 2 hours over unpaved roads to get to a factory in the middle of nowhere somewhere.
Wow.
And yeah, of course, you go now. I was there last month, and you go now, and it's it rivals Manhattan or any metropolis in the world. It's they know how to make stuff over there. They are amazing. I love it.
Yeah. Well, so I mean, you said you were working with these voice chips. but there was no manuals or anything. How did you actually? I mean, do you speak Chinese? Do you like? Did you get those translated? How did you actually dig into those docs and those trips?
I hooked up with a trading company in Taiwan who some of my toy company clients were buying chips from. And they were actually British expats living in Taiwan. And the company owner was married to a Chinese lady, and they had a relationship with all these factories. And they were my interface to the world of Taiwanese chips. So they would take care of me. And before the coding systems were available over here, I would go over with DAT tapes, and I would sit down with the engineers in Hsinchu and code up these chips all from DAT tapes.
Really?
On one trip, I even took my Mac 2. I schlepped my Mac 2 all the way over there so that I could
Wow.
edit stuff on the fly while I was there.
Yeah.
That was fun getting that through customs.
Yeah, I was gonna say
nobody over there had ever seen a Macintosh, but yeah, those were the days.
And so, like, and was that also assembly though? Like, at the end of the day, it was just like peeking and poking the registers, or how were you actually interfacing to these chips then?
The very first generation had almost no logic. You would put your sounds in the chip, and then you had like a paper form where you would check off the triggering options. Do I want it to play this sound twice? Do I want it to play this sound once? Or I want it to play sound A followed by sound B? And it was just and they would crunch it through their stuff. Later on, they came up with rudimentarily programmable. It's a little generous to call them microcontrollers, but they almost were. They were sort of proto microcontrollers. Yeah, it was kind of a state machine. Yeah. And I actually helped one of the bigger players architect their product line. There was a company called Winbond, who's now known as Nuvoton. They're big in the memory business.
Yeah. They make tons of memory. Wow.
Yeah, they're big in the memory business now. Back in the day, they were real big in the speech business. They were one of the first and most sophisticated speech chip makers, and I helped them architect the state machine programmable version. I even named it. Their engineers said, "What should we call this thing?" And I said, "How about Power Speech?" And that's what it became. And I think it's still called Power Speech to this day.
Well, there we go. Where's the royalty check for that one?
And eventually, the coding systems became available. The documentation got better. They got competition, and now it's not a difficult business to get into. And it's pretty much a commodity business. We used to get top dollar for tweaking these sounds and grooming them and programming the chips and so forth. And now it's pretty much any factory in Hong Kong or China will do that part for free just so they get the production business for making the modules.
And so was it basically like an analog to digital conversion process, and then that's what actually the digital bits were compressed down somehow and put onto the Mascrom, like you said, or what?
Yeah, we would do all our sound editing in full fidelity, 44 kilohertz, 16-bit or whatever, get all our editing down and sequencing and so forth, and then you would take those master wave files or AIFF files or whatever and run them through the coding system that would compress it into 4-bit 80 PCM or whatever compression scheme they were using to conserve memory in the chips.
Yeah. I assume you would also want to play it back on whatever somewhat low-cost speaker they were going to use and amplifier as well, just to make sure it sounded okay.
That was the key, and I had to always go around to my sound engineers' offices every other day, and I would say, "Stop listening on those high-cost monitors. You have to listen to it in the 1-inch toy speaker."
Right. It's not gonna, have your kids listen to it, or have your grandkids listen to it, or someone who's going to actually use this thing, right?
Yeah, you have to put that 10-cent speaker into the same plastic housing out of which it's going to play, because the plastic housing would have a huge impact on the sound quality.
Sure.
And if you don't monitor on the target playback system, it's not going to sound right.
That's crazy. And so what were the target? I mean, so you were talking about putting these into. I guess they are ASICs, right? They're application specific. But what was the target cost of a chip like that?
When they first came out, 1991 was the first one. It was 3 seconds for $1.
Oh, wow.
Today you can get 60 seconds for 10, 15 cents. But prior to that, there was only the synthesized speech. There was the Texas Instruments LPC speech, which was, speak and spell.
Right.
Which had a very robotic sound. It was not really recording. It was restricted in what kind of sounds it could do. And that was a $6 chip.
Oh wow.
So
Okay. Yeah.
these things were really revolutionary, and it's all because memory became cheap. Suddenly conserving memory wasn't the prime directive.
Yeah, I guess the thing is like I can read about these things on the on wiki pages or whatever else, even old data books, but I don't really get I don't ever see the price sheets, and I don't even really understand the inflationary effects of like a dollar back then was probably more of the bomb than I even consider it today. And that 15 cents you say today is much less than it would have been back in the early 90s, right? So it seems like a significant cost for what you said was 3 cents, 3 seconds rather of recording.
3 seconds was $1,
Yeah.
which even back in the day was it was a lot. Yeah.
Yeah, yeah, right,
But
right.
it was so revolutionary to be able to put a realistic arbitrary sound into something rather than a synthesized sound. The
Mm-hmm.
first one we ever did was Magic Bottle Baby by Tycho, which
Mm-hmm.
was it just had the sounds of baby sucking on a bottle, but it hadn't been possible before, and that was the first mass produced toy using a Taiwanese recording sound chip.
Right. Well, and like you were saying too, the you could get the premium for the toys back then too. I think I remember like seeing commercials for that kind of thing, and yeah, they would have been super expensive for the that was like the big name at the holidays or whatever.
Yeah, the TV promoted doll, $40 was the normal. 39.95 was the normal price for a TV promoted doll back in the 90s.
Wow, that's pretty insane. Oh yeah, and I see Marvel talking superheroes. Wow, that was another one.
Yeah, we couldn't miniaturize it enough to get it actually in the talking figure, so the sound modules went in a backpack that was on the figures.
So the Hulk wears a backpack because the Hulk
Yes,
goes to
yes.
school too.
All right, yeah, there you go.
Well, so like, what about the effects of like batteries and stuff over time? I mean, you've probably seen. I mean, obviously lithium, because the rise of lithium and stuff, but like something like that what was that doing for? Was it just a tiny alkaline cell, or was it?
Yeah, they're all alkaline A76 or LR44 cells. That's the standard, and that technology really hasn't changed much. It's still 135 milliamp hours, and you still have to be extremely vigilant about your standby current.
Mhm.
A microamp is a lot.
I'm scrolling through all your things here too, and there's just a lot of
So yeah, in the
toys.
late '90s, we had a lot of hits with seasonal goods. We had the first talking, singing Christmas tree, and that was a huge hit. And then we had talking, singing Santa Claus, and so forth. And these all had
Was that
um,
the animatronic eyeballs?
animatronic.
The ones that opened up and down?
Yes, they had a synchronized moving mouth that was in sync with the sound, which I got a patent on that system, I believe.
Right.
What I did was I encoded sub audio, very low frequency control signals, and embedded that in the audio that would control the mouth.
That's awesome.
So we had a good run with those. And then in 1999, I had my best idea, which was also my worst idea, which was for the digital picture frame.
Oh wow.
Digital photography was starting to take off, and I went to Hong Kong or Taiwan or somewhere, and somebody said, show us some family pictures, and of course you would pull out your wallet with some snapshots, and I said, you know what, it would be so cool if you had like something with a little LCD and you could show
Yeah.
them, and that idea blossomed into the digital picture frame. So we developed that in 1999. I brought over a programmer from Australia to work to do that. And we brought it out in 2000. We debuted it at the Photo Marketing Association trade show. We had crowds of people at our booth. The response was overwhelming. We were reviewed very well in magazines. We had retail distribution. We were in CompUSA and Costco and Fry's and
Yeah.
all over the place.
I mean, I remember when these things came out, and I was just like, yeah, that's an amazing idea. But then I looked at the price tag, and I was like, oh boy, okay.
Yeah, it was about $450 when it
Yeah.
came out, because mostly because of the cost of the LCD.
Right. Exactly.
And at the time, digital photography was just starting, so a camera cost $400.
Right.
But still, the response was very positive, and we got off to a great start. And then it was just a perfect storm of bad things that hit. Our LCD was discontinued by our supplier without any warning. which there was no standardization in LCD form factor. So
Sure.
all of a sudden there was nothing that fit into our plastic housing, which we had tooled up for.
Right.
And then the stock market crashed in 2000. So no investors wanted to touch anything having to do with technology.
Right.
So the company died a slow and painful death over the next few years. We came out with a larger commercial version, which was a beautiful product, but it was tough, and we weren't really geared up to sell it. I'm not a very good salesperson. I'm more of a developer, so the whole thing just kind of collapsed.
And
And I took a
this
couple
was
years
your
off.
company, is that right? That was doing
Yes.
the whole development then.
Yes, yeah. I said, when I had the idea for the picture frame, I said, forget this toy business stuff, and this was in the middle of the dot-com boom. This is
Sure.
1999, and anybody with a website idea was getting $20 million thrown
Yeah.
at them. So I said, this will
Pets.com.
be I said, this is a slam dunk. We'll be real engineers with a real product. Here, it's all tooled up, it's ready to go. The packaging is done. We're in production. We have the retail distribution. People are gonna, we'll be drowning in money.
Yeah.
And it didn't happen.
Yeah. And so, I mean, so then as that spun down, like that was basically just trying to sell off inventory, stuff like that.
Yeah, we didn't have inventory. It was basically, trying to keep our houses.
Oh yeah. Oh wow. That's super scary. I mean, like, and that is a realistic part of product businesses, right? Of, you take these huge outlays. I mean, tooling isn't cheap.
Yeah.
You spend thousands
Yeah.
and thousands on molds and
Yeah. And, unfortunately, some of my friends got hurt. But my Taiwanese partners had extended a line of credit that they lost.
yeah.
Some personal friends, I'd borrowed a couple $100,000 from a personal friend that I still haven't paid back.
Wow.
But, it's casualties of war.
Yeah. That's crazy.
So yeah, it's much cleaner to all you people out there with product ideas. It's much cleaner if you license it to somebody and let them have all the fun of making it and laying out the cash for the tooling and the inventory and all that stuff, and you can just sit back and collect your royalty check.
Yeah. I mean, and can you explain that a little bit more too? Because I mean, that always feels like like you see the late night commercials for like, are you an inventor? And like, that's like always the promise of it. But like, what is the reality of licensing, like going through that process and actually getting a signed agreement?
I think it's different in different businesses. Most of my experience as an inventor is in the toy business, but I'm sure it's different in every industry. And the toy business is fairly closed environment. You work with people you know and people who know you, so there's not a whole lot of thievery or bad dealings that go on. These people are professionals and they know they need inventor ideas, and they're happy to pay you.
Right.
Maybe there's some games that go on where they cheat you out of something by reporting returns or losses or defects or something like that. And at the tail end of an item's run, they might say, okay, well, we had to eat some inventory, so we're not going to pay you royalties on that. But that's fairly minor. But, you hear of things in other businesses, like the guy that invented some socket wrench or a ratchet wrench, and he licensed it to Sears, and they just stole his idea outright, and he had to sue them. It took him like 20 years, but he eventually got a very big multi-million-dollar settlement. So
Yeah.
I don't have experience in a lot of inventing outside of the toy industry, but you want to work with the people you can trust, that you have a good feeling about. You hopefully you have a patent. That was another nice thing about the toy business, especially in the days of the sound chip madness, was that you could just walk in and say, they would say, we want you to put a barking sound in this dog. And you'd say, okay, I'll put the barking sound in the dog. You pay me 5%. And they'd say, okay.
Wow. Really?
and that'd be it.
Wow.
Yeah, it was very easy. But, in a lot of businesses now, sure, you need some intellectual property protection, the patenting process, which is very long and expensive, unless you're dealing with people that you really know and trust and can work with on a handshake, or you find a licensee who's willing to work with something that's unprotected, which is also doesn't happen too often. The first thing they're going to ask you if you try to license something, they're going to say, do you have a patent? And if it's something that can be easily knocked off, they're going to say, why should we invest $500,000 in developing this when it's going to be knocked off right away?
Right. That's interesting. So we had a guest on who was a patent attorney a couple weeks ago, and Joe Long's advice was he said people come to him and ask about patent stuff, and the first thing he says to them is, don't do it. And so that's interesting as like another I think he's really saying don't do it unless you really want to, but you're saying that like this, it sounds like a business case for having one.
It gives you a much stronger negotiating position when you're trying to license something. And of course, once your product is out in the market, it may keep potential competitors and knock off people away.
Yeah.
But it's, there are very often ways to get around patents, so they don't always give you all that much protection.
Right.
I'm not a big fan of the patent system. I have 22 or 23 of them granted over the years, and I have a couple more that I'm working on, but they're very annoying.
I think that's another good soundbite about patents. If you're going to do them, they're going to be annoying.
Yeah. They keep rejecting me, saying that my idea is obvious, but it's not. And how do you convince somebody that something isn't obvious? Everything is obvious after you've seen it.
Right. Exactly.
If it's so obvious, how come nobody ever did it?
Right.
First of all. And secondly, I see so many other patents that are obvious. I look at them, I go, how did these people ever get a patent? So it's frustrating.
So you said you took a break for a while, and then
I took a couple of years off. Sold my house, got divorced. Get down to my last my last dollar, and I bought a house out of foreclosure and fixed it up, and then I got a break. A toy industry friend called me around '06 and said, hey, Spin Master is hiring consultants. Would you be willing to move to Toronto? And I jumped on it. I had just gotten married. I left my husband here in Connecticut and moved to Toronto. It was a great gig consulting on site for a fast-growing company. I hadn't actually been inside of a toy company before. I hadn't worked for anybody else, since Electro-Harmonix in '81. Even though I was an independent consultant, I was basically,
right.
my own
you're on
client.
Site, and basically you're yeah.
Yeah, so it was a wonderful experience. So I spent 2 years in Toronto. I would come home for a week every month. It was a great gig.
Yeah, interesting Toronto too. Like I think of Waterloo for tech stuff, but is there a lot of tech in Toronto?
Not really tech, but Spin Master is one of the biggest toy companies in the world now. They weren't at the time. They were probably fifth or sixth at the time, but now they're the third biggest toy company in the world, and their headquarters are in Toronto.
Oh, okay.
Electronics was a small part of their business. It's bigger now, but they do electronics, and I was in charge of electronics company wide.
Oh, wow, really? That's awesome. So what had changed then since you had? It sounds like you kind of stepped away from the toys as you went into the digital frame stuff. What kind of had changed in that interim?
Not a whole lot. I mean, one of Spin Master's specialty is flying toys, so there was some of that, which was new. Actually, what I did a lot of there was feasibility studies on concepts that would come in from outside inventors. Toy Master is very much an inventor-driven company, so they were always receiving submissions by inventors. The marketing guys would look at it. They say, yeah, this is interesting, but we don't know, A, if it's going to work. We don't know, B, if it's going to come in at the price that they claim it's going to come in at. So the feasibility team would come in and look at it and figure out how it would actually be made, how cheaply it could be made, whether it would work. So it's kind of a thankless job of being negative and explaining why these great sounding ideas wouldn't work. But at the same time, it's very important, because if nobody did that, they could spend a lot of money developing something that wasn't going to work out.
Right. Yeah, that risk assessment, especially like on an architectural level, like if you're using a part that you can't get for less than $1 and you say the bomb's going to be 90 cents total, it's like, well, no, you can't do that. So you need to have that up front.
Right. And the inventors, of course, would always lowball the cost. They would say, oh, yeah, you can get this made for $4. And we would run it through and we go, no, sorry, you don't understand how this works. It's going to be $8.
Yeah. Right.
Because they inevitably underestimate the manufacturing costs. When you factor in every single screw and every single piece of tape and every piece of paper that goes into the packaging, it adds up.
Yeah,
and
totally.
All of that is subjected to a waste adder, and it's all subjected to a factory markup adder. So the art of cost estimating is very important. And a lot of new entrepreneurs these days don't have that experience. And that's why a lot of new entrepreneurs get caught up, because they have no idea what this thing is truly going to cost to make. They'll look at their BOM and they'll go, oh, it's an $8 BOM. So I can sell it for $14 and I'll be making lots of money. But
Forex, people, Forex, that's what we use around here.
Yeah.
Yeah. Wow. Yeah. So the toy companies though, do they have a lot of did they have like vertically integrated factories, or was it a lot of contract type stuff and then they would seek out particular factories?
They're independent factories, but in a lot of cases they might almost just as well be captive.
Okay. They go back to them over and over again kind of thing.
Yeah, Mattel will have their favorite factories, and they'll keep this factory so busy that they're doing nothing but Mattel stuff. So they might as well be captive.
Yep.
It's a partnership more or less. Maybe not a formal partnership, but
I was wondering on the cost estimation side of things, like, if you're using rules of thumb, or if you actually were, quoting out jobs and things like that with known factories.
Well, all the toy companies generally have a costing engineer, at least one. So these guys really can look at something and nail it down. They'll actually weigh every piece of plastic and then factor in the cost of the raw resin and the injection molding cycling time for that part.
That's awesome.
So yeah, they really get down to it.
Yeah.
And then, if it passes that first layer of feasibility study here in North America, then they'll send it over to the factories and they'll say, give us a quote on this. But, we can't they don't want to drive the factories crazy with quoting every little thing. So we have to do our homework here first. So the Spin Master gig wrapped up in 2008, and I came back to Connecticut and had to decide what I was going to do from there. I realized that I couldn't really work at home. I had to have a facility, so I found an office not far from my home and rented that, and didn't really have much work. I had a couple of contract jobs from Spin Master, but not a big deal. So it was kind of back to the way it was in '86 when I first started the company, not knowing how I was going to pay the bills.
Yeah.
When out of the blue, I got a call from some people working with Zildjian.
And any drummer out there, immediately their ears perk up. They go, "Ooh, I know that name."
Yeah, it's a legendary name. They're one of the oldest companies in the world. They were founded in 1632, I think. They're still under family ownership in the 15th or 16th generation of the family. Absolutely legendary company. And so yeah, these guys, Zildjian had just hired a vice president of business development, and they wanted to diversify, and he had a vision for electronic drums. And from some long-standing contacts in electronic drum technology, at one point they asked one of the team members, "Well, who are we going to get to do the electronics?" And my name came up, and it just fell into place. And it was one of the most gratifying gigs I've ever had in my life. It went on for 5 years, and I think 5 patents came out of it. Good patents that I didn't have to pay for, which was nice.
Yes.
So yeah, it was great. We spent a year developing an electronic drum kit, and then they turned around and said, "No, we don't want to make electronic drums. We're a cymbal company," which was probably a good decision. And they had these perforated cymbals, which was a technology that was brought to them by Korg. There was a mathematician in Japan who applied these cymbals that were perforated with a Fibonacci series spaced pattern of holes that's similar to the pattern of seeds in a sunflower.
A little biomimicry there, huh?
Yes, and the deal is that they have a much lower sound level output than a traditional cymbal. They have about 25% of the volume. So if you've ever been in a room with a real solid traditional cymbal, they're extremely loud.
Yep. I played in an orchestral band for 8 years, right. So I smashed some of those right in front of my face.
They're really loud. So you can't use them in apartments, you can't use them in some smaller clubs, you can't use them in churches and so forth. So we had these perforated cymbals, but they didn't sound all that great.
Right, and I'm guessing they're not using like the highest quality brass either for those things.
Right. I think they're difficult to make from the cast metal, so they have to stamp them out of sheet metal, which is a lower grade of cymbal. So the vision that this new VP of Product Business Development had was to put a transducer of some kind on the cymbals and then do DSP on them to make them sound good.
Yeah.
And that's what we did for the next 5 years. So it was really a culmination of a lot of things in my career. It was my passion for electronic percussion was in there. It involved hardware. It involved mechanical design for transducers. It involved firmware. There's firmware that goes in the controller and in some of the sensors. It involved ATE. I had to do the production test equipment for the thing. So there's firmware in there, and then there's desktop software that runs the ATE and logs all the test records. So it was sort of, I got to apply everything in my career up to that point was applied to this project, and it was really great. And it won pretty much every award in the music industry in 2011. Best in Show at NAMM, Best in Show at Frankfurt. It was really fun.
Yeah. So could you kind of paint an audio picture of what this looks like for people? Obviously, we'll have pictures. We'll have links over to your site for that, to what it looks like. But like from the transducer up to the box, what does that kind of look like?
Well, a cymbal produces an extremely chaotic cymbal. There are all kinds of enharmonic things going on. In fact, it's a very pure picture of chaos, and the harmonic structure changes over time. When you first strike it, if you've ever seen a very high speed slow motion picture of a cymbal being hit, it looks like it's made out of rubber.
Right,
when you really smash it, the whole cymbal bends and it flops and it goes back and forth, flopping.
Well, it depends where you hit it on the cymbal too. I think that's important for people to know. Like if you hit it with the edge of your stick on the edge of the cymbal, you were going to get a loud friggin' noise versus like the tip of the stick on the middle of the cymbal or the center of the cymbal, you're not much noise at all.
Right. Yeah. If you hit the bell with the side of the stick, you'll get a ding, ding, ding.
Yeah, exactly.
If you hit the middle of the cymbal, what they call the bow, you get a ting, ting. And if you hit the edge, you get a crash.
Yep.
And these are all the subtleties that you generally don't get or don't get very controllably with the typical electronic cymbals, which are just a piece of plastic with a simple piezo transducer on them. Mm-hmm. So you'll get amplitude response, but you'll always be triggering the same stored sound. So the beauty of the Gen 16 acoustic electric cymbal was you were really hearing the sound of the metal, but we were processing it. So anything that you could do with sticks or mallets or your hand or anything would still work. You can do all the subtleties, but we're processing that to make it sound better with the DSP.
Yeah.
In particular, people love the hi-hat. The hi-hat is a very complex instrument where it's a foot pedal, operates when you press on the foot pedal, the upper and lower halves of the hi-hat cymbal come together. So there's really a very infinitely expressible range going on there and a lot of subtlety, and no one has ever done a really good electronic hi-hat.
I completely agree with that. My former company had a set, like a $5,000 set, like really, really nice ones, and I would play it, I'd be like, it's not the same, your stick doesn't bounce the same, it just doesn't feel the same.
So there's a lot of people who did not fall head over heels in love with the sound of the Gen 16 cymbals, in particular the crash. A lot of people didn't like the crash. The ride had some issues with the bell sound, but it's pretty much universal. Everybody loves the hi-hat. So there are a lot of people who now have hybrid kits where they have the Gen 16 hi-hat and then they'll have more traditional sample triggering cymbals for the other ones.
That's interesting. So I had thought this was just a pure trigger device when I first saw it too. I didn't quite realize that it was the filtering like you're talking about. So like
it's stick on metal.
So when it goes through, so basically you have a transducer, it's effectively like a piezo again? Is that kind of the idea?
The original version had some condenser microphones that were underneath the cymbal, which had terrible crosstalk and feedback problems, which I warned them about. I said, this is going to have terrible crosstalk and feedback problems, but it was really a matter of, we had to get it to market that year or the project was going to be killed. So unfortunately that kind of got rushed to market. But as soon as that went out and was a success in the press and so forth, I immediately went back to the lab and I said, I have to come up with a sensor that's going to work better. And I came up with a patented solution to this, which is I took a condenser microphone and potted it in epoxy and put it into a machined stainless steel or aluminum actually aluminum housing that screws directly onto the cymbal. So basically, what I did is I made an accelerometer out of an electret
Oh
microphone.
yeah, that's nice. Yeah.
Accelerometers, typical accelerometers like the monolithic accelerometers, generally do not have the frequency response that you need for audio.
Mm-hmm.
They generally crap out at about a kilohertz. There are 20 kilohertz accelerometers, but they're like $50
Right,
items.
right.
So by taking an electret microphone and putting it in a soundproof enclosure, I basically made a high frequency accelerometer.
Mm.
And then that would screw directly onto the cymbal. There's a little preamp that goes under the cymbal, which has all kinds of neat lighting effects. Beautiful
gotta have the bling,
design.
right?
Yeah, beautiful industrial design there by a company called Gyre 9, not too far from here. And then the preamp signal then went to the digital cymbal processor. And going back to our previous conversation, there's power line carrier involved.
Oh, really? Okay.
Yeah, I didn't have any extra wires. It's there's like 60 feet of cabling and a complete drum set, so I couldn't put extra conductors in the wire. It would have been very expensive. So I've already got power going to the preamp for the lighting effects. So I just superimposed some modulated high frequency carrier on the 12-volt DC supply going out to the preamps, and then I decode that with a microcontroller in the preamp, so you can issue lighting controls from the cymbal processor out to the preamps to change the lighting effects.
That's super cool. And then basically, so like there's a micro in each lighting thing you're saying as well.
Yes,
Okay.
yes.
Was that doing any pre-processing before it sent the audio signal back to the central
No,
processor?
just for the lighting.
Got it. Okay. And then what did the DSP actually look like in the on the processor side?
It's a Blackfin, Analog Devices Blackfin, which I did not design. It was done by another contractor out in California called Damage Control.
Mm-hmm.
I think it's a bit of an antique as far as DSPs go, but it's I wasn't involved in the vendor selection for that, and I think it's something that they had and we could get to market with quick, so we used that.
Got it. Got it.
There were significant EMC issues with that project. The controller had really bad radiation on the first iterations because the Blackfin was a 266 megahertz processor and it had external RAM. So that was the project where I learned all about EMC, which has
right,
which has since become another business for me, is EMC mitigation, and that was the start of my EMC career.
I was also wondering, because I see on the bottom of each of your site pages as well that you're a microchip design partner, and I was curious about that process and like what that kind of looked like getting into that. Well, like what it is first, maybe so people know.
Well, I've always gravitated towards PICs. I think I first really started using PICs in earnest around 2006. Prior to that, I'd worked mostly with 4-bit microcontrollers, which obviously are not suitable for a lot of things anymore.
Yeah, still used though.
So I needed
right?
something. Yeah, I guess. So I needed something with a bit more juice, and PICs had always been kind of legendary as being fairly easy to use and powerful processor. So I got with them in 2006 and been using them ever since.
Cool.
And I guess I became a design partner 2 years ago or so.
Okay. I just always wonder, like, does that bring you more work though? Like I see the listing on their website and other similar things.
It has not brought me any work, no. Supposedly it will bring me some kind of commission on chip sales if I ever put a PIC in something that has high volume, but
okay.
That'll probably never happen because I use PICs in low volume stuff. I use them in ATE or that kind of stuff. If anything was going to go into high volume, it would probably end up in a Taiwanese chip for 2 cents instead of $2.
Right. Yeah. So basically, this is your kind of return product. I mean, it sounds like 5 years since you kind of came back to the industry, but then this is your big one.
Yeah, it was. The Gen 16 was kind of full circle on my career, getting back into percussion, 30 years later or whatever it was. And as I said, kind of tapping on everything I'd ever learned about all facets, from the mechanical to the software and the firmware and the hardware, the test equipment. We did pneumatic testers, life testers for cymbals. We had to hit cymbals really hard a million times to see if they would break. So I built pneumatic testers. It was so multidisciplinary. It was wonderful. And they wrapped up. They stopped development in 2014. They still actually make the product, but they stopped developing new stuff.
Oh, okay.
The business development guy and I had a vision for where we wanted to go with it, and we knew what we needed to do to take it to the next level. But the Zildjian management decided that they had spent enough money on development and they wanted to get some return on their investment.
These things happen.
So that wrapped up in 2014, and I got variety of business from various sources. I had this IoT medical dispensing device that was a project from an Australian client that came to me by way of the factory that I had worked with in China, who built the Zildjian stuff. And then at this point, I started getting EMC consulting work. TUV Rhineland of North America. TUV Rhineland is one of the world's largest testing laboratories. They're like UL, but they're German.
Right.
And their North American headquarters is 5 minutes from my office.
Oh,
and they have a full EMC lab there. And that's where I actually successfully got the Zildjian cymbal processor to pass EMC testing, and they were so impressed with the job I did on that, they started referring clients to me for mitigation work.
Nice.
Being a testing lab, they have a conflict of interest they can't advise customers really on how to solve their problems, and it's not really their business. So they would have a customer who would try and couldn't get their product to pass testing, and they'd say, look, take it over to Julia and she'll set you up. She'll solve it for you. So that's become a side business for me, is doing the EMC mitigation.
Nice. Well, what are some, I don't want to, take your business away here, but like, what are some of the high level issues that you see? I mean, is it usually clock based stuff, or is it bad layouts, or what does it usually look like from your perspective?
It's usually bad layout. I mean, for radiated emissions, it's usually bad layout. It's usually a poor understanding of ground planes and how ground planes work. It's all about minimizing the impedance of the RF ground returns.
Yep. Big, thick ground planes are my friends. I definitely push for that all the time. I'm like, well, and I asked about this on, maybe not on the Kicad board, but on the consulting board I run. And it's just like, these days I just go straight to 4-layer because like, it's not worth failing,
There is no reason not to use a 4-layer board these days. Yeah. It's crazy.
Yeah.
And there's a lot of misunderstanding about how they actually work, what they do. People think that copper floods on the signal layer is the same thing, but
no.
as we know, it's not. That's not a plane.
No, sadly not.
They may be in the same plane, but it's not a plane. So,
right.
But the neat thing about that consulting work is that I never know what's going to walk in the door.
Yeah,
one day it'll be a battery charger, and the next day it'll be a giant 3-ton paper processing machine, and the next day it'll be a heart defibrillator. So, and it's extremely challenging because by the time they get to me, the internal engineers have already been working on it for 6 or 8 months or more without any success. And management is fed up, and they're like, you got to solve this now. We have orders waiting to ship. And you've never seen it before. You have no idea how it works. So you've got to get up to speed on this thing really quickly, figure out how it works, find out why it's failing testing. It's really in a heavy pressure.
Yeah.
It's fun. It's rewarding.
Have you ever walked into a room though and been like, you scratch the chin, look at it, and then put your finger somewhere, and then it starts working? Because that's always like that's the true magic.
I have actually.
Oh, you have really?
I have it. I have actually, and it's really it's tough because you realize when you do that you haven't charged them enough.
Yeah, right.
I had one job where the guy had been working on this for, I don't know, he must have been banging his head on it for like 6 months. He couldn't get this thing to pass. And he was convinced that it was the shielding on the connectors. And this thing had a lot of cables. It had a 44-pin cable and had a lot of power going over that. And he was convinced it was in that 44-pin cable. And he kept putting more and more expensive connectors on that cable. The $30 connector didn't do it, so I put a $60 connector on it. Oh, my God. And I'm sure I can see the stuff leaking out there with my little sniffer probe.
Oh, my God.
And then I saw there was a cable coming out of it going to a foot switch that operated the machine.
Oh no.
I said, I said, what about this wire? He said, nope. I said, I measured the common mode current on that wire, and according to the Henry Ott book, that should not make enough field strength to put me over the limit. I said, "Oh yeah, well, okay." And so I put I put a ferrite on each line of it, and boom, it passed.
Oh man!
So
there it is.
It was like 30. It was like 30 minutes of work.
Yep.
And you know, I probably saved that company about $30,000, and I got paid.
Jeez.
You know what, 500.
Yeah.
So,
oh man. Yeah, and I just saw that Henry's retiring. Did you see that? He's finally retiring. Yeah. So Henry has been on the show before, but I think he's in his 80s. He's got to be. I mean, he's up there, and he's done.
Henry's been on your show. Wow, he's one of my heroes.
Yeah, his book's amazing, and he does a bunch of training and stuff. But maybe I'm talking to the next Henry Ott right here. So
I don't know. I tell you who else is great in that field is Keith Armstrong. You know Keith Armstrong?
I don't.
He's the British Henry Ott.
Okay, nice.
Really nice guy. Really nice guy. I've reached out to him a couple of times, and he's responded to my emails.
That's great. Yeah, and I think that's the thing. It's like it's not a huge industry when you really get down to it. You know, like EMC testing. Like, how many people you're really going to call? How many labs are there? And it's like it's but everybody has to solve this problem still. So it's really important to get the baseline stuff right.
Yeah, and there's a lot of intuitiveness, and you really have to, you have to stop thinking of the electrons as bobbling along nicely inside their wires, because
right.
When up at the hundreds of megahertz, you have to start thinking about fields.
Yep. Yep. It seems like you've also kind of started doing 3D printer stuff. There's a bunch of 3D printer stuff on your
Yeah, I got
page.
I got my first 3D printer in 2012. I had kept an eye on the rapid prototyping industry for a long time, and of course, everybody knew about SLA machines when they were a couple $100,000.
Yeah,
and then then they started becoming about $10,000 in the 20 teens, and I started thinking about it. Maybe I could start thinking about getting something like this. And then in 2012, I saw that there was a home printer from China, of course, called the Up. And it was like $2,400. And I said, you know what? I have to buy this. I don't know what I'm going to do with it, but I have to buy it. I have to know what's going on in this world. And maybe I'll find a use for it. And I can't imagine being without one now. I think I have 6 or 8 of them.
Yeah.
And it was a life changer. All the times back in the toy days in the 90s when we used to hot glue the plastic sheeting together and go to the hobby shop and cobble all this. But now it's just, you draw it up in the CAD, you send it to the machine, and an hour later you have your part. Yep. So it's just been a game changer. Yep. And I actually made a little cottage industry out of it. Manufacturing printer accessories for a Polish printer called the Zortrax. Zortrax it's a closed system where they tried to encourage people to buy only their materials by not allowing the user to control the temperature and other parameters of the printing process. Uh-huh. So I reverse engineered their system, and I came up with a temperature controller for it. It turned into a nice little cottage industry for a couple of years. It's tapered off now, but we make a line of 5 of them. I get my production line is my husband. Mm-hmm. I say, honey, we need some more Z-temps, and he comes in for a couple of days and puts them together.
Nice. I wouldn't say free labor, but included labor, perhaps.
Yeah,
that's great. Well, and so like to circle back to what we were talking about at the beginning. So now you're doing Kicad or Kicad for some for development, and I was wondering like how that's worked out for you, from the consulting world and reception to doing that kind of
thing. I've always been on the lookout for good ECAD stuff, and learning curve is very important to me. So the ones I've used Express PCB, mm-hmm. Yep. Which I love very much. It's like so incredibly intuitive and so unrestrictive in terms of creating parts. There's no library system. You can just make stuff up on the fly.
Right, which is a double-edged sword. It sounds like experienced person like you would say it's fine, but maybe beginner might be a little dangerous. course.
And for simple designs, you wouldn't want to do anything super complicated in it, but the learning curve is really short. But it's kind of a dead end manufacturing wise. Yeah, you can't, to get the Gerbers, you have to pay them another $65. So they want you to buy the boards from them. So at one point, I was doing EMC consulting for a French 3D printer company, and I got them to buy me a copy of Eagle, which I absolutely cannot stand. It's got one of the most user hostile UIs I've ever used.
I will say it's gotten a little better, but not that much better. They had to keep pleasing their users, so. But some people love it.
Yeah, it's user hostile. Just goes against all user interface conventions from the GUI
so
era.
Of course you switched to Kicad then, right?
Well, I had actually checked in with Kicad every couple of years, I guess. I remember back in when did it start, in the 80s or early 90s?
I think 90s.
And I looked at it. It was it was a joke. It was a toy. There was nothing there, and I said, "Oh, this is ridiculous. I can't use this." And then I checked back in, sometime not that long ago, I guess, 3-4 years ago, and I said, "Whoa, this has come a long way." I guess it was in the early days of version 4.
Yeah. Yep.
And I went briefly into Design Spark. I did one design in Design Spark. And while it was better than Eagle, I still wasn't crazy about it. Mm-hmm. So I was still looking for something more, and I switched over to Kicad. And frustrating as it was in a lot of respects, I did get adept at it and learn to tolerate its more frustrating aspects.
We call it quirkiness.
I stuck with it till the present day, and I'm glad I did, because version 5 is just it's a whole new world, and I really love 5, and I love the direction it's going at. I had sort of given up hope of them ever embracing a standard UI, with mm-hmm. things like copy and paste.
Oh yeah,
but much to my astonishment, V5 has copy and paste.
Yeah,
and you can actually duplicate and copy symbols fairly easily once you remember the magic incantation. So yeah, it's pretty great. There are certainly some things I would love to have, but unfortunately it's not a commercial product, so there's not a really great channel for putting in feature requests.
Well, maybe there will be in April. And you said you might come to the conference in April?
Possibly.
Okay. All right.
But yeah, given a choice, I would rather pay for something that's supported commercially.
Yep.
But I'm sort of coming over to the open source thing a little bit, just in terms of longevity. Of course, a commercial product can always be discontinued, and then you're really SOL.
Yep.
So I'm embracing the open source thing a little bit, but still, I'd be happy to pay for it if there were a little bit more input into features and so forth.
Yeah.
But once things get to a certain size, it's very difficult to get responsiveness. So
yeah, we always talk. Well, we used to joke on this program about we need something like not a red hat to the fedora of ECAD, but we need a lead hat. Right. So instead, but I mean, that's kind of the idea is that's what Red Hat basically was, is a support layer and like a pay for features kind of thing. And you pay for support contracts from that company. Yeah. Maybe someday we'll see. So what's the future for you? I mean, you're back to consulting. You're obviously doing lots of EMC stuff. I mean, what are you excited about?
It's my career has turned into power right now, power distribution.
Oh, cool. Okay.
So, I'm working on crazy high current stuff. I'm doing, hundreds of amps.
Whoa.
I did, I've done some ATE that involved 100 amp testing of stuff, and now I'm actually designing data centers and UPSs that
nice.
Involve 100,000 kilowatt UPSs and data centers and so forth. So that's a whole new world. I'm learning about 800 amp circuit breakers that cost $6,000.
Oh my god!
So from microamps to to kiloamps.
Yeah, right.
It's crazy.
I was going to say, just learn with one hand behind your back. It sounds like that's potentially dangerous. Yeah.
It's scary because, yes, people can die and millions of dollars of equipment can go up in smoke. So it's much higher stakes than anything I've ever been involved in.
Well, that's exciting. I think when I think about, obviously I've only been doing consulting a couple months now, but like the thing that I like focusing on, obviously I've been thinking about New Year's goals and stuff too. And just like, skill building is like my main focus right now. And it sounds like you've been doing that through your whole career of like just building skill after skill after skill.
Always as required to get the job.
Yeah.
It's never been, I've never sat down and said, okay, I'm going to go into this field and I'm going to learn about this so that I can maybe get some work. It's always the other way around. It's always
interesting.
The customer comes along and says, can you do this? And I say, sure. and then I figure out how to do it.
Right. It's back calculated.
Yeah. But the most important thing is integrity, delivering a really high quality product, delivering it on time, delivering it on budget, being professional, documenting, communicating.
Yeah.
I can't work with people who don't communicate.
Mm-hmm.
And I'm all about the emails and the copying everybody on the emails and not conducting business on the phone or on Facebook
or Slack.
Slack. Documentation has become a lost art.
Yeah.
You buy software programs now and it's like, well, how do you work it? Where's the documentation? There isn't any.
Right.
So I'm all about professionalism in those respects, and the quality clients appreciate the quality work.
Yeah.
And the clients who don't care about quality, well, I don't want to work for them.
Right. Yeah, I mean, you basically price yourself out of those jobs anyways because you're like, well, this is my price. I don't want to work for someone who would lowball me or whatever.
Exactly.
Yeah.
Yep.
Well, Julia, thank you so much for telling us about. I mean, like this is quite the journey from the audio days up to present. It's a lot of stuff, and I really appreciated hearing about all of it.
Thank you, Chris. It's an honor to be on the podcast.
Okay, well, I hope to see you soon at Kicad conference. Talk to you later.
All right. Take care. Bye.